That's where I want to start with this lesson today. And for everything on the notes, at least, is just absolute value. But when you get to the homework, your homework is going to ask you to graph absolute value equations and linear equations. So you need to start and identify, is this absolute value or is it linear? So with the opener here, I see the absolute value brackets. That should be an easy giveaway. If the parentheses are those straight lines, those are called absolute value bars, it's an absolute value function, and we should expect the graph to be a V shape. And so we're going to focus on kind of coming up with a set of rules for how we can graph any absolute value function. The opener, the only thing I want to remind us about is kind of the order of operations when plugging in values. This isn't how we're going to graph every absolute value function. Okay, so we'll just do this for one x value, just to kind of review that, because we also did this at the very beginning of this unit. It was lesson 0 that we did this exact same thing. Okay, so if I want to figure out the y value when x is 1, I'm going to sub that in. So 1 minus 3 minus 7. I have to take the absolute value of that. But before I take the absolute value, I'm going to simplify what's inside those brackets. 1 minus 3 is negative 2. Then we have to take the absolute value of negative 2, which means to turn it positive. We only do that when taking the absolute value of a number. Okay, so the fact that I'm taking the absolute value of negative 2 is why I'm making it positive 2. It's not that anything inside the absolute value brackets we just make positive. It's only when we take the absolute value of a number. So this becomes y equals 2 times positive 2 minus 7, which is 4 minus 7, which is negative 3. So we get 1 point here at 1, negative 3. And that's really all I want to do for this opener. Hey, again, just refresh ourselves as to how we can plug in x values into an absolute value function to get the corresponding y's. And instead of graphing that way, we're going to come up with very similar sets of rules of how we graph linear functions. So I actually feel like graphing absolute value equations is even easier than graphing lines. Okay, there's a lot less kind of subtleties with it. So let's come up with these kind of rules that we're going to follow here. So absolute values will always be written in the form that we call its vertex form. And that's because we can identify the vertex from the equation. And let's start with that. Your vertex comes from the number that's added onto the x, just like point slope form of a line, right? We get an x coordinate from what's inside there, and the sign is opposite. Okay, then that value of k, that's the y coordinate of our vertex. So h comma k is the xy of the vertex. We need to remember that the value of h, or the x coordinate of the vertex, has opposite sign. Okay, so if it's negative in the equation, it's positive when we graph it. If it's positive in the equation, it's negative when we graph it. Then k, that's going to be the y coordinate of the vertex, and that sign stays the same. So same sign. So just like with graphing lines, we got to figure out where's our first point we're going to graph, and it's always going to be that vertex point. So we'll identify the vertex point, we'll put a dot there. Then this a value here tells us a couple things about the graph. The first thing that it tells us is whether or not it opens up or down. So if that a value is positive, we're going to get a V shape that opens up. If instead the a value is negative, then that flips that V upside down and kind of makes the letter A. The last thing that the a value is, it's essentially our slope. Okay, which is rise over run. Okay, and I'm going to put slope in quotations because it's not really the slope because it's not constant, right? With linear functions, we say slope because it's the same slope for between every single point. For absolute value, we're going to have one line that has a positive slope, one line that's negative, and so it's not constant, okay? It's at least constant in terms of what we're going to do with the rise over run, but because we have one slope positive and one that's negative, it doesn't follow that definition of being constant. All right, so let's do two graphs together. And these graphs go really quick. That's why, again, you're going to get quite a bit of time in here to work. And a lot of you might even finish this homework assignment in class today. And the only thing you'd have to work on this weekend are your quiz corrections. Okay, but walking through this whole thing. So first off, the a value, number after the equal sign, that is 3. I still like writing it as a fraction. That way I know what my rise over run is. Okay, so 3 over 1, it opens up. And the vertex is at 0, 0. Okay, I don't see any number added inside the absolute value brackets or any number that happens after. So I'm going to plot 0, 0 first. And then for the slope of 3, or the a value of 3, I'm going to go up 3 and over 1 in both directions. So up 1, 2, 3, over 1. Then up 1, 2, 3, and over 1. We get our 5 points and the V-shaped graph that opens up. Okay, quick, easy, not much to it. For number 2, the a value is -1/2. It opens down because of that a value being negative. Then the vertex, the x coordinate is 4, and that's coming from that -4, or the x -4 in the equation. That sign is opposite. And then y coordinate is 1. That sign stays the same. So I'm going to go plot that point, 4, 1. And for the rise over 1, I'm going to go down 1 and over 2 in both directions. All right, any questions here? All right, go and flip this page over. And on the other side, you have 4 equations I want you to graph. I do want you to graph all 4. We'll say like 4 minutes, 1 minute for each graph. We'll check those, and then we'll just write equations given the graph, and get you going on the homework. And I'm going to have you earn your homework today, just like what we've done in the past. All right, so everybody graph 3, 4, 5, and 6. We'll check our work and then move on to the last part of this. Give you a few minutes. For number 3, a value is 2, so our rise of run is 2 over 1. It opens up. Again, the x coordinate, the sign will always be opposite from what we see in the equation, so that makes the x coordinate -4. The sign of the y coordinate stays the same, so at -5. So that vertex is left 4, down 5. I go up 2 and over 1 from there. Number 4, the vertex, I see that I have an x plus 4 inside the brackets, making the x coordinate -4. The y coordinate, there's nothing there, so it's just 0. So our vertex is just shifted left 4, and then we go up 4 and over 3 in both directions. Okay, so not much different than the ones that I had just gone over. Okay, but any questions with either one that I have up here? All right, we've got 2 more. Okay, so 5, that vertex goes up 5. There's nothing inside the parentheses, so it doesn't shift left or right at all. Then the a value, -2, so I'm going to go down 2 and over 1 in both directions. That's how we get our graph. And then the last one here, number 6, vertex is at 2, 0. It opens up and has a slope of 1/5, so I'm going up 1 and over 5 in both directions, so that makes it really flat. Right? We're not really able to fit 5 points on there. I guess we could. That over this direction take us a little bit off. But because of how flat and how spread apart those points are, it's okay to just have 3 there. All right. We got one last thing to do with these, and that's just if I give you a graph, can you write the equation? Okay, and if we're able to graph them, it's not much different, right? We just need to figure out what is the slope Is that slope going to be positive or negative? And then what are the coordinates of the vertex? And then remembering to switch the sign on that x coordinate. Okay, so how this is going to go, I'm going to do 7 and 8. 9 and 10 are how you're going to get your homework. So I need to see 9 and 10 for you to get your homework today. Well, let's do 7 and 8 first. All right, so 7. The vertex is left 2 up 3, so at negative 2, comma 3. To find the a value, I'm just going to start from the vertex, and I'm going to find the rise over run. Okay, so I'm having to go over 1 and down 1, 2, 3, 4. It is going down, so that a value needs to be negative, so it's negative 4 over 1. Then, taking all of this information and putting it in the equation, it starts with y equals, followed by the a value, and you can say just negative 4, or you can put negative 4 over 1, I don't care. Followed by the absolute value brackets. Okay, if you don't have absolute value brackets, you're not writing an absolute value equation. That part's really important, and a lot of students will use normal parentheses here. It's not normal parentheses because it's not a line. Inside those brackets will be x plus 2. That negative 2 makes it positive 2 in the equation, followed by plus 3 at the very end. All right, and the last one's here. Vertex here is at 2, 1. The a value is definitely positive because it opens up. I'm having to go over 2 and up 1, 2, 3, making it 3 halves. So the equation is y equals 3 halves. Absolute value of x minus 2 plus 1. All right. So again, 9 and 10, once you're done with those, bring them up to me. If they're wrong, I'll make you go fix them. If they're right, I'll give you the homework, and the rest of the class will be your time to work on that homework.